Today we're going to be learning about roots. That includes square roots and cube roots. Make sure that you set up your notes like you're supposed to, the Cornell way, and that you have the topic and essential question listed on your notes. Alright, squares and square roots are first. Numbers such as 1, 4, 9, and 16 are perfect squares because they are squares of integers. Think about the number 4. 2 times 2 gives us 4. The number 9, 3 times 3 gives us 9. So these are all numbers that we get when we have exponents of 2. Squaring a number, that means raising it to the second exponent, and finding a square root are inverse operations. In other words, one operation will undo the other operation. So I have something squared, I can take the square root of it and then just have the number. If I have a number with the square root, I can square it and then have the number. A square root of a number is one of its two equal factors. For example, what is the square root of 9? The square root of 9, what number times itself gives us 9? 3 times 3 gives us 9, so it would be 3. All right? The radical sign, for some reason this is messed up. It should look like this. A radical sign is used to indicate a positive square root. We're only going to be dealing with positive square roots. Every positive number has both a negative and a positive square root. So, for instance, 16, I could do 4 times 4 gives me 16. Or negative 4 times negative 4 also gives me 16. So, negatives and positives give us the same answer up under the square root. Let's look at these examples. The square root of 9 over 16. Okay, when I have the square root of a fraction, I can split it up and say the square root of 9 over the square root of 16. So when I'm looking at this, I'm asking, what times itself gives me 9? 3 times 3 gives me 9, so that would be 3. And for 16, what times itself gives me 16? 4 times 4 is 16, so the square root of 16 is 4. So the answer to that one would be 3/4. All right, on B, plus or minus the square root of 0.81. The number I see here is 81. So I'm thinking, what times itself would give me 81? Well, that would be 9. 9 times 9 gives me 81, but I want 0.81. 0.81. So that would be 0.9. 0.9 would give me 0.81. So some of these are just going to be trial and error. You're going to have to actually try the numbers in your calculator and see what will give you the correct answer. Example C. Now if I've got a negative on the outside of a square root, then my answer is automatically going to be negative. Then I'm looking, the square root of 49, what times itself gives me 49? 7 times 7 gives me 49, so the square root is simply 7. So negative 7 is that answer. All right, the last example, example D, the square root of negative 100. Well, think about this. What times itself would give me a negative 100? 10 times 10 would give me positive 100. Negative 10 times negative 10 would also give me a positive 100. So, without using imaginary numbers, which you won't do till way later on, there is no solution to the square root of negative 100. So, no solution. You cannot take the square root of a negative number. All right, moving on. Cubes and cube roots. Numbers such as 8, 27, and 64 are perfect cubes because they are the cubes of integers. Okay, so if we think about this, look down here. 8 equals 2 times 2 times 2 times 2. So that would be 2 cubed. So when I'm taking the cube root, I'm looking for what times itself 3 times gives me this number. Okay, for 27, 3 times 3 times 3 gives me 27. For 64, 4 times 4 times 4 gives me 64. So the cube root of 8 would be 2, the cube root of 27 would be 3, and the cube root of 64 would be 4. A cube root of a number is one of its 3 equal factors. If you look at this symbol right here, it looks like the square root symbol, but it has a 3 right there. That's used to indicate a cube root of a number. Okay, looking at these examples. On example I, I've got the number 729. I'm looking for the cube root of that. Now on these, a lot of times you're going to have to do trial and error to figure out what's going to give you the right answer. So 729, I know equals 9 times 9 times 9. So the cube root of 729 would equal 9. Okay, now on J, I said that a square root cannot be negative. However, a cube root can be negative. That just means that my answer is going to be a negative. So, negative 64. We went over this on the last slide. I can get that by doing negative 4 times negative 4 times negative 4. So my cube root is negative 4. So, hint, if you see negative inside a cube root, your answer is always going to be negative. Always. Okay, for K, last one, 1,000. What times itself 3 times gives us the number 1,000? You can try lots of numbers. I know it's got to be greater than 9 because over here I got 729. So 10. 10 times 10 times 10 gives me 1,000. So the cube root of 1,000 is 10. So the main thing to remember is these can be negative. Although with square roots we cannot have a negative inside the radical, with cube roots you can. Last thing, solving equations with roots. In order to undo a variable squared, such as x squared, you should take the square root of it. So for example, I've got x squared equals 25. To solve that, I'm going to take the square root of both sides, which is what I did right here. The square root of x squared equals the square root of 25. The square root of x squared, that radical sign and the exponent of 2 cancel each other out. So I'm left with x equals, the square root of 25 is 5, because 5 times 5 gives me 25. Okay, looking down here, in order to undo a variable cubed, such as x cubed, you should take the cube root of it. So I've got, for example, x cubed equals 8. Taking the cube root, notice my little 3 that's right there. The cube root of x cubed equals the cube root of 8. That radical sign and the exponent of 3 cancel each other out. So I'm looking at what times itself 3 times gives me 8. 2 times 2 times 2 gives me 8. So my answer is x equals 2. Alright, let's look at solving some of these. Y squared equals 81. To undo that, I'm going to take the square root of y squared and the square root of 81. That radical sign and the exponent of 2 cancel, and I'm left with y. The square root of 81. What times itself gives us 81? 9 times 9 equals 81, so y equals 9. Number 2, c squared equals 9. Taking the square root of c squared and the square root of 9. The radical and the squared cancel, so I'm left with c. The square root of 9. What number times itself gives me 9? 3 times 3 is 9, so the square root of 9 is 3. Number 3, taking the cube root. B cubed equals 27. The cubed root of b cubed and the cube root of 27. The cube root and the 3 exponent cancel, so I'm left with b. The cube root of 27, what times itself 3 times gives me 27? 3 times 3 times 3. So 3 is my answer. Last example, number 4. The cube root of x cubed equals the cube root of 125. My radical and my exponent cancel, so I'm left with x. The cube root of 125, what times itself 3 times gives me 125? 5 times 5 times 5. So x equals 5. All right, now I need for you to take out your book and complete page 126, 1 through 16, all. Okay, all of them. I have also posted on where you went to this video a PDF of this page. So if you happen to not get finished in class, you have it on Canvas to be able to work out. Okay, this is due at the beginning of class tomorrow. I will check it for a homework grade. If you have questions, please, please, please come ask.